Welcome to Opsrace training program. In this series, we will talk about APIs. APIs for everyone. Who should learn? Backend engineers, front-end engineers, manual SQL engineers, automated SQL engineers, and DevOps engineers. So all these people need to learn the APIs, what they are, how they work, and then finally we will look at couple of example how can we build REST APIs. So this is all about the API itself, what is protocols, how protocol works, why it is important. REST API, this is also a protocol, what are the best practices, and some hands-on as well. Okay, so number one question is, what is an API? So an API is an application programming interface, is a way for two or more computers to communicate. So this is basically communication between two computers. The way, the technique, the process they follow basically is called application programming interface. Okay, so what is an interface? We just saw the definition. Let's focus on the interface part. So this is a very classic television you can see here. So this is an interface. This is a human or a user interface where user can interact with these buttons to change the channel. They can interact with this volume button, they can interact with this power button. So this interface is for human, this interface is for user to interact with this machine. Okay, this is another interface at the back side of your television, and this interface is not for human, this interface is for the external devices. If you want this television to be connected and to an external device, you can utilize this interface. So if you want to plug your audio, so you can audio system or your speakers, so you can use this place or these jacks or these ports. If you want to connect your video source, maybe a VCR or maybe your VCD or DVD player, so you can plug them. So there are multiple options that you can utilize to plug the input or to plug the output as well. So this is an analog interface, whereas latest television have all these digital interfaces where you can connect the displays, and you can also connect it with the internet. You can also use USB ports, HDMI ports. So there are a lot of ports. This VGA port is a very older one to connect cathode ray monitors to it. But this is just an interface to connect a different set of devices, a different set of digital devices to this television. With the passage of time, the infrared technology were used in your television, and using remote control, you don't have to get out of your chair, table, or whatever wherever you are sitting. So you can change these channels, you can change volume, etc. Now, in order for this small device, this remote control, to interact with the television has to provide an infrared interface so that it can be connected. And now, due to this modern world, everything is connected with the Wi-Fi. Even your televisions are smart, they are connected with Wi-Fi devices which has internet. Your mobile is connected with Wi-Fi devices, so you can directly communicate with your television using your mobile phone. And for that, television has to provide the Wi-Fi interface, the technology, the relevant softwares, the relevant embedded system that can help us to connect our mobile devices. So these are a couple of examples of the interface. So we look at the user interface, the back analog interface, and then at the back we saw digital interface, then the buoy that we used to interact with the same interface, but we just changed the technology, and then came the infrared, and finally Wi-Fi. So what is an interface? It's a way to interact or instruct the system. I hope this is now clear. Let's look at the interaction. So if this user want to interact with this piece of hardware, so this hardware provides an interface, this keyboard, a tracking pad, or a mouse. You can connect a mouse in order to interact with this machine. But what if we want to interact with a software which is inside this system, a program inside this system, running inside this system? So if we want to interact with that, for that this program has to provide an interface. So let's say this person want to rate a song by Avas Kazmi. So he can go, there would be some UI screen where he can press these rating stars, etc. After that, this would be submitted. So how this person can rate a song? For that program has to provide him the interface. This is a user interface which enables this person to do the ratings. So just imagine if this machine want to play some song whenever you put your clothes in and you start the washing process, and this device wants to play some music. It wants to interact with this music playing software, Winamp or Jet Audio, whatever that is. For that, the software has to provide an application programming interface. So this is the interface which can be used by other machines, other software. So if you want to play some song from your device, you want to control it, for that again you need to provide an application programming interface so that you can interact with that program. If user has to interact with that program, so user will have a user interface, UI. If programs or application needs to interact with it, so application programming interface would be provided. I hope it's clear now what API is, what is interface. So what is communication protocol? So this is very important for learning the API, or especially the REST API. So it built on top of stack of protocols, so we need to understand. This is the definition: a system of rules that allows two or more entities of a communication system to transmit information via any variation of a physical quantity. Okay, let's decode this definition. So these are two persons, they want to communicate. So one way is they use the telepathy, where this man injects his idea or whatever he wants to tell this person in his brain. So direct brain to brain communication if he has the skill of the telepathy. What if he doesn't have this skill? The other way is to use sign language. So maybe he's telling him to bring me a glass of water, and this person may understand this. This is I love you in ASL, American Sign Language. So they both need to understand the same communication. This communication was not possible because this person didn't have these skills. His brain was able to receive the communication, but this person was not able to transmit that. Whereas he now knows the ASL language, which is the sign language, whereas this person is unable to understand what it is. Now there is a physical medium that they will use, is the sound waves. So he may communicate through sound waves. So this is a third medium in our example, where this person may be able to generate it, or this person may be able to consume this signal. So what if this person is mute? So this sound communication cannot happen, okay, because he cannot produce this sound waves, and hence he would not be able to listen. On the other hand, if this person is not able to receive this sound wave, that means this communication will not happen. So we are using a medium, a physical medium, which is the sound waves, but we are having trouble with the devices, the communication, the transmitter and receiver, if they are not working. Let's say they both listen, he can say words, he can listen to that, but this person tells him off with a zine. Now this person is unable to understand. He know the word, he may be able to replicate the same sound, but he does not understand what is the meaning of off with a zine, whereas this person is clearly communicating this. So the medium they are using, they both know the medium, they both understand the sound medium, their devices are working perfectly fine, because he can produce the sound, he can consume the sound. His brain also received the message of with a zine, but it's not able to interpret it. In communication, it's very important you define a protocol. Protocol is a set of rules which will define how the physical communication will happen, what type of communication will happen, and how it will happen. Either I have to interject in between the conversation or not. So these are certain set of protocols which needs to be defined in order for the communication to happen. So this person tells him, I don't understand. So this is a shake hand or connection is being established where this person tells this person, I understand sounds, I can receive sound, I do not understand this language. So if you need to talk to me, you have to talk to me in English. So then this person's using the same medium will say goodbye. Now this person understand it, and now this person will react to it. So that's how protocol works. Also, I have tried to explain two concepts here. A protocol may be consist of multiple stack. So one protocol can be built on top of another protocol. For example, this person tell this person, I can hear voices. So you would have to communicate in audio form or in the sound waves. Okay, this is one protocol, one communication, which is a physical protocol. And then he tells him, on top of these sounds, I want to hear things in English. So this is sound wave protocol, this is English language protocol. So English language protocol is built on top of sound wave. If there are no sound waves, then he won't be able to listen this. The other way would be if we send him the text message, and in text message he writes this goodbye. So that means we have changed the protocol. So it's very common. We built one protocol on top of another and on top of another. So there could be multiple stack of protocols for the communication. I hope things are clear. If not, please comment below. If you like it, then tell me what did you like the most. Okay. Now we talk about TCP/IP protocol. It's a very important. You may have heard this terminology again and again. So it is a stack of communication protocol. I will explain it in a way that you understand its importance. Okay, so what happens if in the browser we type opsrace.com? What will happen? It will try to find out the server which is hosting this website. How would it find? It will basically talk to DNS server. So browser are programmed to automatically connect to DNS server, and from there they can get the IP address where this site is hosted. It's not that simple, but just for this lecture I have simplified it in a greater detail. So this browser first talk to the DNS server, and from there it asks him to give me this address. So this is basically the address. Then the browser knows the address, then it can directly talk to the server which is running our code. So maybe this is our PHP code, this is Java, or maybe there are multiple websites running on a single server on this IP address. So once we get the IP address, this browser can now connect to this server to exchange the information. So IP, how IPs work? So IP is very important to hop or roam around the network. So internet is basically a combination of lot of networks. They are connected, and your data routes through these networks. So they may have simple routers. If we look at here, so there are a lot of layers over here which I have simplified. So this computer, if need send to message to this server, it has to use the TCP/IP protocol, where IP protocol will help him to reach that machine, to reach that server. So once the packet or the communication is established or initiated, at that point it land to this router, where router has two interfaces. One is basically 192.0 till 192.99. So this traffic will go here, and if the range IP range is in this 100 till 200, so that traffic will go here. So the IP address we are interested in is 192.58. So that means we have to jump here, so our packet will jump to this router. Now this router again split the traffic into two portions. There could be multiple points, it depends on the number of port on a router. But again, this is logical, this may not be exactly the same, but that's in spirit how these things work. So the traffic 0 to 50 has to go to this server, and from 51 to 99 to this server. So now our packet, our traffic, our communication will jump here. Similarly, it keep on jumping different routers until it reaches the destination. So that's how IP addresses or IP protocol help us to reach a destination. This is your address, your home address, your machine address, which is publicly listed. This IP address will keep changing if you restart the internet, or if your router is restarted, if you haven't if you are not using a static IP address. Okay. Now the TCP protocol. So TCP is transmission control protocol, which is actually responsible transferring the data, transferring the information. So let's say this is a file or this is the data. This protocol may split into small chunks, because you really can't transmit big files, because there may be a problem with the internet, there may not be a capacity on the wires, on the signals that we are using. So there could be 100 of reasons where you cannot transmit this data as a singular file. So these protocol basically split into small chunks, and then those chunks are transmitted, whereas the server side receive these chunks and then rebuild all the file, all the data again. So TCP protocol is a very important protocol. It not only create different packets, different sequence, it also acknowledge like which of the packets it has received. So if it is unable to receive a single packet, it will tell the server, it basically won't recognize it, or if it wants to close the communication, it can then tell this machine or this sender that I haven't received this packet. So that packet can be resent, so that we don't have to lose the complete file, we don't have to lose all the data. So if this loss will happen, this will be a small chunk which we can request again, because whenever these packets are sent, a number is associated with them, a sequence number. So let's say this was 1 2 3 4. So as soon as first packet is received, it will acknowledge received 1. Now if you see, this is the fourth packet, but due to internet path or internet routing, this packet is received earlier than the previous one. Now the fourth packet is received here, it will place it here and acknowledge like fourth packet is received. So as soon as the packets are being received, it keep on acknowledging that. And just because these are all sequence, so it can combine them, join them together. So this is the capability of TCP protocol. Another protocol which is of similar kind, it is UDP, where UDP does not acknowledge receiving of the packet in order to increase the speed, because every packet that is transmitted and then receive, it acknowledges it slow down the process. So in UDP you don't acknowledge generally what you have received. So another important concept is 4 layers of the TCP IP model. This is basically part of the OSI model, OSI layers model. We'll discuss this in a separate series. So number 1 layer is the application layer, where your SMTP protocol, this is basically for sending and receiving email. HTTP and HTTPS protocol, this is used to browse the internet, so the web pages can be accessed through this. FTP is file transfer protocol, where you can transfer a file from your desktop to a remote location and from remote to local location. So this is a very different sort of protocol. SSH is to connect a remote server to run different commands. We will discuss them in a separate series, but for now we are interested in HTTP and HTTPS. um, as I explained, a protocol can be built on top of another protocol. So HTTP is built on top of transport. So this layer is dependent on the transport layer, or HTTP is built on top of TCP. TCP is the one which breaks down the information data into small packets and then transmit it over the internet, whereas HTTP is specific, which understand the HTML. It takes the HTML, so all that communication between a browser and a web server happens with the help of HTTP. So HTTP uses the same TCP protocol, and then TCP protocol depend, or transport layer depend on the internet protocol. Transport layer depends on the internet protocol, so there are a couple of internet layer which has couple of protocol. IP version 4, so the last example we looked at it was IP version 4. Then there is control message, etc., and ARP. We don't need to go to in detail for these messages. We are interested in IP version 4, which is currently used. IP version 6, it would be the latest. Then once the IP will help us to locating the exact machine, or the help us to reach the destination, then network access or physical layer is also involved. So what this will do is, all this data that we discuss will be in the forms of bits. So this is the digital data, this is in the form of packet, but what will happen on the physical devices, so maybe your network card, your Wi-Fi card, how they will manage. So that physical part, that communication, that cable or fiber optic or whatever that is managed by this. So basically your data is traveling through a connected wire, your data is traveling through Wi-Fi signal, your data is traveling through the fiber optics in the form of light. So all physicality, all that transmission, all that transport has to happen. Their network access layer is involved in that. So this is physical layer. It contains 3 sub layers of the OSI. We don't need to go into detail. So this is a simple. This understand the HTML part, this understand breaking down of the information into small packets and route them. This help in the routing to find the correct address. So this help us in exchanging that digital information into maybe an electric signal, a radio wave, or into fiber optics. This also include the MAC address part as well. So I hope this makes sense. All these things are relatively not that complex. If they are, please comment below. See you in the next lecture, where we will discuss about HTTP over TCP protocol. Thank you. Take care. Bye.